In this video, we are going to look at constructing a confidence interval for a population mean when the population standard deviation is not known. So here we do not know the value of the population standard deviation. Right? Just because we don't know the value of the population standard deviation does not mean we don't know a standard deviation. We will make use of the sample standard deviation in this setting. All right, so here we have, again, notationally, mu is our population mean. That's the thing we don't know, but we want to come up with a confidence interval for. X bar is our sample mean. S is our sample standard deviation. And again, that value, n, is the sample size. Right, so in this setting, as compared to the last one, the only thing that is different is we have a standard deviation that is a sample standard deviation instead of a population standard deviation, right, in terms of the initial information. Now, the way we go through and calculate things, other things trickle through and are different slightly as well. So namely, we will use a t-distribution to come up with our margin of error instead of a z-distribution. All right, so procedurally, we check and observe that the sample is a simple random sample. The population should be normally distributed, or we need to have a sample size greater than 30. So once we have that, the t-distribution will make sense. We will identify 4 things again. So those 4 things, they include first the confidence level, then the sample size n, then the sample mean x bar, and then finally the sample standard deviation. This time the standard deviation is for the sample instead of the standard deviation for a population. Oh, and that notation there should no longer be x bar, or it should no longer be sigma. So that is not a sigma. That should be an S. We are identifying a sample standard deviation. All right, so how do we roll with this? In StatDisk, we choose analysis, confidence intervals, and then a mean for one sample. Same thing we chose in the last setting. We input the confidence level. We input the sample size. We input the sample mean, x bar, and we input that sample standard deviation, s. All right, so let's look at an example. So here we have a random sample of 40 Chips Ahoy cookies, found that the mean number of chocolate chips was 24 with a standard deviation of 3. Right. So this seems pretty familiar. Seems a whole lot like the example we saw last time. 40, what is that? That is the number that are in the sample. N is equal to 40. So let's read this sentence again. A random sample of 40, blah, 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 found that the mean, blah, 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 was 24. So that 24, that is the value of x bar. That is the mean specifically for the sample. So random sample of 40 found that the mean was x bar with a standard deviation of 3. So 3 is a standard deviation, but this time it's a standard deviation that is specifically for the sample. So it's no longer sigma is equal to 3. It is now s is equal to 3. All right, so let's answer some questions again. What is the best point estimate? So if we can only guess one number for the mean number of chocolate chips in all Chips Ahoy cookies, if I can only guess one number for the mean, my best guess comes from the mean for our sample, 24 chocolate chips. Next, we want to find a confidence interval, a 95% confidence interval. So our confidence level is 0.95. So we're going to take that 0.95, the 40, the 24, and the 3 all over to StatDisk. So let's go to StatDisk. In StatDisk, I'm going to choose Analysis. I'm going to choose Confidence Intervals. We're trying to find a mean, a confidence interval about a mean, and we're only dealing with one sample. So I choose confidence interval, mean, one sample, and let's enter our information. So 0.95, that is our confidence level. Our sample size here is 40. Our sample mean, so the mean that came from the sample was 24. And our sample standard deviation was 3. We don't have a population standard deviation, so that's the only way this problem differed from the one that we did in our last video. In our last video, that 3 was a population standard deviation. In this video, it's a sample standard deviation. So let's evaluate that. And when we evaluate that, we get 23.04 up through 24.96. So our confidence interval is shown there, 23.04055 to 24.95945. 23.04 to 24.96. So that is our confidence interval. Our margin of error was 0.96 chocolate chips. We can go back to StatDisk and look at this again. Right, so our margin of error is right there at the top, 0.95945. So if we rounded to the second decimal place, it's 0.96. Can we confidently say that the mean number of chocolate chips is greater than 23? Yes. Why? The entire confidence interval is above 23. Can we confidently say that it is less than 26? Yes. Why? The entire confidence interval is below 26. Could we confidently say that the mean number of chocolate chips is less than 24.9? No, because 24.9, there's values in this confidence interval that are more than 24.9. So 24.95 is in that confidence interval. And there are values that are less than 24.9. All we can say is we think that the confidence interval, that interval from 23.04 up to 24.96, we think that actually contains the mean. We can't say anything about where we think it is. All right. That's it for that example. Notice that example is really, really similar to the one we did in the last problem. In the last video. The only thing that was different was the standard deviation was a sample standard deviation in this one as compared to a population standard deviation. Our numbers here, this confidence interval, 23.04 to 24.96, that was really subtly different. So instead of 23.04, in the last one we had 23.07 and 24.93. So there's really, really subtle changes in that, but there are changes that have an impact. All right, we'll talk to you in our next video where we try to determine sample sizes in order to estimate population means. We'll talk to you then.